Where's the inside-most part of the function? X to the fourth. It's the inside part of the trig function. Okay, so that's what we're going to let our u be. All right, so we're going to let u be x to the fourth. All right, I'm going to take the derivative of both sides. Du is equal to, derivative over here will be a 4x to the third, and you can't forget the dx. Okay, derivative there, take dx. Solve all the way down for dx. So du over 4x to the third. All right, then you're going to come back up. All right, and it should all fall out nice and neat like it did on our first assignment. We'll have the integral. All right, I don't have anything to replace that 4x to the third, but that's okay because I see it right here. It's going to cross out. All right, 4x to the third is going to stay put. All right, the sign is going to stay put. I'm going to replace x to the fourth with a u. I'm going to replace dx with what it equals. So du, and then 4x to the third. Okay, so that 4x to the third that was in the original problem and the 4x to the third down here, opposite locations, so we can cross them out. So just like we did on Monday, everything is going to cross out. They're just now going to be the trig functions, and you're going to have to then make sure you have all your trig integrals memorized. Okay, so can we integrate sine? What do we get when we integrate sine? Negative cosine. Negative cosine. So negative cosine u, and then plus c. All right, replacing the u with that x to the fourth to get the answer back in terms of x. So negative cosine x to the fourth plus c. All right, so not that it's any harder. The concept is the same. You're going to pick that inside part. You're going to cross things out. As long as everything crosses out, we are good. All right, when things don't cross out, then it gets a little bit more not so good. All right, let me give you one more and let you try it on your own before we go to the definite integrals. Okay, so let's integrate sine x over a cosine to the third x dx. I will help you out a little bit to get you started. All right, do we have an inside part? Can't see, this is this, so I'll start you out here. Is it hard to see an inside part? For some of you, it may be hard to see it. All right, so if it is, remember in trig, we took a 3 that was right here and moved it out on the outside. So then we rewrote it so that it looked like a cosine x to the third power. Remember doing that last year? All right, and the only reason I like to do that is because then I can more easily see cosine x is that inside part of the function. All right, some of you are going to be able to see it without doing that. All right, but if not, that's fine too. Okay, so I'll start you out. So obviously then we're going to do the inside part of that function, which now we know is cosine x. Okay, now from there, I think you guys can go the rest of the way down. So I'll give you a hot second. All right. Okay, so we took the derivative of both sides. Everybody wrote down du is equal to, what did you write down there? Negative sine, because this is the derivative of cosine, so negative sine x. Okay, so at this point now, your derivatives and integrals are going to get a little mixed up. You might drop that negative, forget. Okay, so really important that those are memorized. Okay, so du over negative sine x is equal to dx solving all the way down. Okay, all right, then we're going to come back up here and we're going to start substituting. Okay, I don't have anything for the sine x, so that's going to stay on the top. I let u be cosine x, so I'm going to have a u to the third right here. I'm going to replace dx with what it equals, so I'll have a du up here. And then I'll have a negative sine x on the bottom. Okay, hopefully at this point everything's going to cross out nice. I have a sine x on the top and I have a sine x on the bottom. So clearly all my x's are gone. I've got this little negative that you can't forget or lose. It needs to come out in front or that I would recommend you bring it out in front. It's going to make it easier. So negative out in front, we'll have an integral. All right, since we're here still at the beginning, let's make that a 1 over u to the third du. Okay, we can't integrate it like that. We need to get something raised to a power, so I'm going to use laws of exponents. I'm going to move that up. Negative integral u to the negative 3 du. Now I'm actually to the place where I can integrate. Now's when the integral sign goes away. All right, now I usually do, since there's a negative out here in front, I do that. I go square bracket, then I know inside my square bracket is where I'm doing my integral here. Let's see, negative 3 plus 1 will give me a negative 2. Because I added 1. And then that'll give me a negative 1/2 in front. Did I do that right? Then plus c. Now I can look at that and say, okay, negative times negative is going to give me a positive 1/2. All right, u to the negative 2 plus c. Now I'm going to take, I think at this point, I think what I'm going to do is I'm going to plug it back in now before I move it. And I'm going to, so that you guys can see this, plug this in here. Cosine x to the negative 2. I'm going to write it just like that. Now, it's a negative exponent. I can't have that, right? So I'm going to move it down and I'm going to make it positive, but I'm still going to kind of keep those two things separate at the moment. All right, because this now is going to be a 1 over, and then I'm going to have cosine squared x. I put the 2 back on the inside there. Okay. Anybody get to that point? Anybody get a 1 over and then in the denominator 2 times cosine squared x? Okay, now, you're not wrong at that point. You are right. However, they want you to be even better. From trig, do you remember a substitution that we can substitute for 1 over cosine squared? How about just 1 over cosine? Something you can, we did it when we were focusing on that when we verified our trig identities. 1 over cosine is equal to, not cosecant, secant. It's the reciprocal identities. Okay, so we learned the reciprocal identities. I'm going to write it down next to this. Okay, we learned things like 1 over cosine is equal to secant x. Okay, that's what we learned. Okay, now, and remember my little memorization trick. All right, sine, cosine, tangent to me are my normal trig functions, and that starts with a S or a C, and so then that means my reciprocal identity has to start with the other letter, which is the S. All right, and if I have my regular normal sine, cosine, tangent over here, then these are all my weird ones, so secant, cosecant, and tangent, okay? If you remember, that's kind of how I described it last year. Now, that's what was on our formula sheet. That's what we memorized, but then I said you could take each one of those and you could do a 1 over a cosine squared x is equal to a secant squared x. You can do squareds on all of them. They're not on the formula sheet, but those are equivalent. All right, and we could do it. And we probably only did this one day last year, and it was when we were verifying those trig identities. All right, so if it's not in your long-term memory, then that's probably why. Totally okay. That's why we're reviewing now. So this is going to be I'm going to put them together. We're not going to have a dot in our final answer. All right, so then I'm going to have, well, I guess, no, wait a minute. That's just horrible. I don't want to write it like that. Let's write it like this. Let's go 1/2 secant squared x plus c. All right, this is the answer they want you to get to. All right, they don't want you to leave something where like 1 over cosine squared, you can change that. Okay, and this, believe it or not, will be the hardest step because you're going to have to recall things from trig, some of those formulas, how to make those substitutions. Okay, now minus this stuff here, how was all of this up to this point? Pretty good up to that point. Should have been fine, right? Anybody by chance get all the way down to here? I was just checking.